Hey Simran, Simran, wake up! Why are you sleeping? We have a test today.
Oh yeah.
Trig identities, you remember?
Oh yo man, I was just stuck on this one problem.
Which one? Which one are you stuck
Yo,
on?
I was stuck on 12B.
Yo, I'm stuck on the same question! Well, what do we do now?
I don't know, bro.
Oh, I know. Grab your iPad. We'll search up like the video on
Mom,
YouTube.
do my iPad. Thanks, Mom. Do
Let's
it.
go on YouTube.
Okay, these are our learning goals. So by the end of this video, you'll be able to recognize and apply different identities. You'll learn how to prove identities using different methods. You will learn to substitute identities into the problems based on what you are given. And finally, you will use basic identities to prove more complex identities.
Okay, so now I'm gonna prove this trig identity. I showed that it's the same using common denominators. So at first, we're gonna work with the right side here. So right side where we're working with. So we're gonna write down this 1 over 1 minus cos theta minus 1 over 1 plus cos theta. So now we have to make the bottoms the same. So I'm gonna multiply this by this and this by that to make the denominator same. And whatever we do to the bottom, we have to do to the top too. So we're gonna have 1 minus cos theta. This is gonna be multiplied by 1 plus cos theta. This also gonna be multiplied by 1 plus cos theta. Minus, it's gonna be multiplied by 1 minus cos theta. You have 1 plus cos theta. Multiply 1 minus cos theta. So now we're gonna combine the denominators. At the bottom we're gonna have 1 minus cos theta times 1 plus cos theta as our denominator, and at the top we have 1 times 1 is 1, 1 times cos theta is cos theta, so 1 plus cos theta minus, then we're gonna distribute here, so we have 1 minus cos theta. So now we have one fraction instead of two, and we made the bottoms the same using common denominators. So now what we're gonna do is we're gonna distribute this negative sign to the bracket here. So we have 1 plus cos theta minus 1, and then the minus and minus become the plus cos theta. Now we can cross out the 1 here and the negative 1. So this is still all over. We can write this as 1 minus cos squared theta. So now this cos adds with this cos. So now we have 2 cos theta over 1 minus cos squared theta. So I'm going to bring this on to this side. So again we have 2 cos theta over 1 minus cos squared theta. So now we're going to use the Pythagorean identity, and we're going to isolate for 1 minus cos theta. So if you take the cos theta over here, it will be 1 minus cos squared theta, so then we're left with sine squared theta. So 2 cos theta over 1 minus cos squared theta, as you can see, is equal to sine squared theta. So you can do that with that, and then we can also change the sine squared theta into tan squared theta times cos squared theta using the quotient identity. So we can isolate for sine squared theta is equal to tan squared theta times cos squared theta. You have tan squared theta multiplied by cos squared theta. So now what we can do is cross out 1 cos and cross out 1 cos here. So we're left with 2 over tan squared theta times cos theta. So now if we look at the quotient identity again, we can know that cos is equal to sine theta over tan theta. So we can change the cos to have 2 over tan squared theta times cos theta can be changed into sine theta over tan theta. So now we can cross out one tan from here and this tan from here. So we're left with 2 over sine theta times tan theta. And as you can see, this is equal to the right side, so we can conclude that the right side is equal to the left side.
So first what we do is multiply the denominator, this side, the left side is the side that we're working with. We multiply it with the opposite, basically the conjugate of it. So 1 over sec theta minus tan theta multiplied with tan theta plus sec theta over tan theta plus sec theta. So now we get tan theta plus secant theta over secant squared theta minus tan squared theta. So now using the Pythagorean theorem identity, we can replace tan secant theta squared theta. So tan theta theta plus 1 minus tan squared theta. So tan squared theta plus 1 is equal to secant squared theta. So now we can just simplify. So tan squared theta subtraction tan squared theta. So tan squared plus secant over 1, because these two cancel out, is equal to the right side, which was tan theta plus secant theta. So therefore you can say our left side is equal to our right side.
Okay, so now I'm going to teach you guys how to prove trig identities using expanding. So here's the question: cos theta bracket cos theta minus secant theta equals negative sine squared theta. So our first step is to turn our secant theta into its reciprocal identity, 1 over cos theta. So we'll have cos theta times cos theta minus 1 over cos theta. So after that, we'll have to multiply our cos theta into the brackets, cos theta minus 1 over cos theta. So once we do that, we'll have cos theta squared minus cos theta over cos theta. Now that we know that anything over itself is equal to 1, so we can simplify this into cos squared theta minus 1. And if we go to our Pythagorean identities, we know that cos squared theta is equal to 1 minus sine squared theta. So we can simplify this or substitute this into here by doing 1 minus sine squared theta minus 1. And then we just collect like terms, so it's rearranged into negative sine squared theta minus 1 plus 1. Minus 1 plus 1 cancels out, and we're left with negative sine squared theta, and it's equal to negative sine squared theta. So we just proved that the left side is equal to the right side.
Go.
Alright, so now we're going to solve trigonometric identities using all the different types of identities. If you don't understand what that means is, so far we've gone over the different types of identities. So that's the Pythagorean identity, the quotient identity, and the reciprocal identities. So basically now what we're going to do is we're going to get more complex, and we're going to start using them in more complex equations where you have to use all of them and not just one of them. Alright, so this is one of those questions where you're going to have to use all the different types of trigonometric identities to help prove it, okay? So this is like trigonometric identity equation, the question that we're going to start off with. So it says sine theta times cotangent theta plus sine theta times tan theta equals secant theta. Alright, so what we're going to start off with is obviously sine stays the same because sine doesn't have another trigonometric identity. But cot, if you look at the reciprocal identities, cot is equal to 1 over tan. In other words, that's also equal to, wait, let me just put this in brackets. It's also equal to cos theta over sine theta. Alright? And just to help with this multiplication, we're going to put a 1 under here so you can see that. And then we're going to do plus, and then we are going to continue. It says sine theta, just like before, it doesn't change. But then tan is going to be the quotient identity, and that's going to equal to over 1. That's going to equal to sine theta over cos theta. Just the flip of what cotangent was. Alright, and then this is all working on the left side because we want to work on the left side right now. So I probably should have written that down before. Alright, so at the end we're going to end up with secant theta, okay. So now if we want to multiply this, we can see that this sign over here is dividing with this over here. So when you're multiplying it, these two cancel out. So at the end, we're going to be left with cos theta over 1 plus, and then over here you can see that we don't have the same thing, so we're gonna have to change that up a bit. And when you multiply these two, this to become the same identity, you have to multiply this cos into that and this one into this. Alright, so when you flip it like that, it's gonna become sine theta squared, because there's two signs now, and then you're going to divide by cos theta. Alright, so now what we're going to do is to make these two the same denominators, we're going to have to make it to, okay, so we're going to multiply this cos into this cos over 1. Alright, so we're multiplying that cos into there, you're going to end up with cos squared. It's going to end up being 1 times cos theta. Okay, and on the same side, we do the same on the other side, which would be 1 times cos theta squared. Oh, yeah. And it'd be 1 times cos theta. Alright, so you can see that we have the same denominator, and 1 times cos theta is obviously just going to stay as cos theta. And then with the same denominator, you can just add the numerators on the top, which is going to equal to, oh, whoopsies. It's going to equal to cos theta squared plus sine theta squared. And with that, cos theta squared plus sine theta squared, which is also known as the Pythagorean identity, is equal to 1. And on the bottom, we have a cos theta. And if we go back to our, over here, if we go back to our reciprocal identities, we can see that sec is equal, or not sec, secant is equal to 1 over cos. So this 1 over cos is equal to secant theta. And as a result, we have just proved that the left side equals to the right side. Man, Ishan, that video helped a lot.
Now we're gonna get 100% for sure.
Let's go. Oh,
Okay.
yeah.